All right, new situation here. So notice that here I am in quadrant 2. And in quadrant 2, we have x is negative and y is positive. And then in this situation, I'm going to give the x value. So I'm going to come down here, and we're going to give the x value. And x value on the unit circle is cosine. So x here on the unit circle is cosine of theta. And let's say the cosine here is -4/7. So that's my x value. And what I want to do is I want to find the sine of theta based on this information up there. So important things to know. If I'm playing with sine and cosine, those are x and y values on a circle, specifically the unit circle. And then anytime we're talking about points on a circle, the Pythagorean theorem can be applied if I draw it in right. So from this point up here, I came down perpendicular to make a right triangle. And I know that this side of the right triangle, this leg, is -4/7. And I want to know what is this leg right here. Now, since this is the unit circle, I know the radius is equal to 1. So I have enough information on this triangle now to find the y value. And if I find the y value, then I also know the cosine, because on the unit, the sine, excuse me, because on the unit circle, y is the sine of theta. So what do I know? Pythagorean theorem here tells me that x squared plus y squared equals 1 squared. And in this case, I have x equals -4/7. Always use parentheses when you substitute in. One squared, let's do the easy one, that's 1. Y squared is y squared at the moment. And then if I square a negative, I get a positive. So 4 squared is 16, 7 squared is 49, oops, plus. So we need to subtract that over the other side. So y squared is 1 minus 16/49. 1 can be viewed as 49 over 49. Let's see, 49 minus 16, how about 33? Good idea to check that on a calculator, make sure we're getting it right. And then to get rid of a square, I take the square root. So then I get y equals plus or minus, we have to make a decision, square root of 33 over 49. Now I know I'm in quadrant 2, right? That was part of the information I started with here. So that means y is positive, so I only want the positive version. So for me, I just want the positive one. And then 33, that doesn't sound special, 3 times 11, but 49 I know is 7 squared. So that means I can rewrite this as the square root of 33 over the square root of 49, and I know the square root of 49 is 7. So square root of 33 over 7 should be the y value here. Okay, so what do I know? I know that if I'm in quadrant 2 and the cosine of some angle theta, that being the angle theta there, is equal to -4/7, then the sine of that angle theta, I don't even know what theta is at the moment, has to be the square root of 33 over 7. All right, how could I double check that to make sure it's right? Well, I would whip out a graphing calculator. So let's give that a shot. How could I double check this? So I do expect you to do all this work. A graphing calculator will give us an approximation for that number right there. And actually, let's calculate that number to see if it looks reasonable on the graph. I'm going to use Desmos. Come on, Desmos. Get out of the way, zoom. I want to know what's the square root of 33, get outside of the root, and then divide by 7, and I get about 0.82. How does that look like on my picture? So this y value is approximately 0.82. Yeah, close enough. Seems reasonable. All right, so reminder about circles. We played with the standard form of a circle last time, and I just wrote the equation of this circle right here. Any point you pick on this circle has an x coordinate and a y coordinate. X is located over here, y is located over there. When we plot points, right, we usually think about going over x and then up to get y. So maybe I'll draw that like this right here. And that makes a right triangle there, where this leg of the triangle is x, this leg of the triangle is y, there's the right angle and there's 1. And the Pythagorean theorem says that's the relationship between x, y, and 1 because it's a right triangle. So I can whip this out on a calculator. And I used Desmos and Geogebra last time. I think I'm going to switch to Geogebra this time. And I already drew here the circle x squared plus y squared equals 1. I'm just going to start over with a new graph. Open, save. Where do I get just a new one? I think I get a new one. Just maybe deleting that right there. I don't want to save the changes. All right, so in GeoGebra, and Desmos works the same way. You can just go type here, x raised to the second power plus y raised to the second power equals 1. So there's my circle, and I can zoom in on it a little bit. Incorporating the other information about this problem, so I was given that the cosine of the angle theta was -4/7, and I know the cosine is the x value. So I want to identify in this graph places where x is -4/7. So I'm just going to enter that into my calculator. So again, I'm checking my work here by graphing it. So I'm just going to type x equals -4/7. And so I get this line here, it drew for me. And so this is one point where x is -4/7, and here's the other one. And I was told my point was in quadrant 2, which is this one right here. And so my program here tells me that if you start off with x equals -4/7, then y is going to be about 0.8, is what I'm told. Now, again, the computer won't give me the exact answer. I have to do a significant amount of work to find that myself. So I had to apply the Pythagorean theorem and solve, get the exact value of the y, which happens to be the sine there. All right, so let's see. Moving along in section 3.